Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to make a tax-deductible donation to support our students at Illinois State University, you can find information about you can just make a donation directly at this website, smarturl.it/help-ISU-actuary. Here's the first written answer problem from the last exam MLC from fall 2017. For a fully discrete 10-payment 20-year endowment insurance with a benefit of $100,000 issued to a 50-year-old, you are given mortality follows the illustrative life table, interest rate is 6%, reserves are calculated using the full preliminary term method, initial expenses are $500 plus 40% of the gross premium, renewal expenses at each premium payment date after the first are 50 plus 4% of the gross premium. Gross premiums are calculated using the equivalence principle. The first part A question is two-part. It asks to show that the gross premium, PG, is 5340 to the nearest 10. We should calculate the gross premium to the nearest 1. And the second part asks to calculate the expense loading, PE. Then part B asks us to calculate the expense reserve at time 1. Part C asks us to explain why the expense reserve at time 1 is negative. Part D asks us to calculate the full preliminary term reserve at times 1, 2, and 19. And Part E asks us to explain the rationale for the FPT, full preliminary term method. And here is the solution. For Part A, we use the equivalence principle to find the premium. So the premium pays for a death benefit and all the expenses. That's basically what you see in this equation. Note that we split the first year expense into the part that is only in the first year and then the ones that are recurring expenses, so that 500 from the first year becomes 450 that is only in the first year and 50 that is in every year after that, so that we can write this as an annuity due. And the same for the percentage of premium expenses, 0.36 that is only in the first year and then 0.04 in every year including the first. Also, the problem says that expenses are incurred only on the premium payment dates. So the expenses, annuities are 10-year annuities, even though the death benefit and endowment benefit are for a 20-year endowment. Then, using the illustrative life table, we can write A:50:10 as A:50 minus 10E50 times A:60, and now we use the illustrative life table and plug in the numbers from the table so that we can find that 10-year annuity due to be annuity on a 50-year-old, but a 10-year, to be 7.5736182228. Then we recall the David Ricardo formula that says that if you borrow $1, you can pay interest on it as long as you live and pay it off with the death benefit of 1. And based on it, A:50:20 is 1 minus D A:50:20. D is I over 1 plus I, so in this case it's 0.06 over 1.06, and we write the A:50 as a 50 colon angle 20 as a double dot 50 minus 20 E50 times a double dot 70. And from the illustrative life table, we plug in the values for those, and after all the calculations, we get a 50 colon angle 20 to be 0.360839617. And then we solve the initial equation for the gross premium. PG is 100,000 times a big A 50 colon angle 20. That's the actuarial present value of the death or endowment benefit, plus 450 plus a 50 A double dot 50 colon angle 10 divided by 0.96 A double dot 50 colon angle 10 minus 0.36. All of these values we actually have calculated, so we plug them all in and we get the premium to be 5,341.395835. And this is 5340 to the nearest 10. For the second part of this part A, we note that the level expense premium pays for all expenses. So on the equivalence principle basis, we have that the premium for the expenses paid over 10 years when expenses are paid, it's equal to the gross premium times the percentage of premium expenses, plus 50 a double dot 50 colon angle 10 plus 450, and in both cases you can see again that we split the first year expense into the part that is paid the first year and the part that is the same as the expenses in the renewal years. So this is an equation in which only PE is unknown, PG we just calculated. So we solve it for PE, and we obtain what you see, PG times the whole quantity of 0.04 a double dot 50 colon angle 10 plus 0.36, plus the fixed expenses, not percentage of premium, so 50 a double dot 50 colon angle 10 plus 450, and the whole thing divided by a double dot 50 colon angle 10. All of these quantities we have calculated before, so we plug them all in, and we obtain 576.9674409. Now, to calculate the expense reserve at policy duration 1, at time 1, we just take the reserve at expense reserve at time 0 plus the premium paid for the expenses minus the actual expenses incurred at time 0, and then we accumulate that 1 year actuarially into a policy duration 1. And of course 1E50 is equal to V times P50. Now P50 is not in the table, but Q50 is, so 1 minus Q50 from the table is going to be P50, and 1.06 and negative 1 is V in this case. The expense reserve at policy duration 0 at the beginning is 0, plus the premium for the expenses we just calculated, minus expenses at time 0, which is 40% of the gross premium, and 500. And after all this, we get, we plug it all in and we do the calculation, and we get negative 2,196.167659 approximately. And of course, you could do this prospectively, but why? You would have to go through a lot of painful calculations. It's completely unnecessary. Retrospective calculation is by far the best in this case. Well, for Part C, we note that mortality increases with age, and with level premium for life insurance, this creates a need for a reserve to use leftover early premium for future higher mortality costs for which the future level premiums are insufficient. That's why reserve for mortality benefits is positive, the standard insurance and life insurance reserve. It makes sense to have it because mortality increases and the premium is level. Expenses are large at first and then decline, so it's exactly the opposite of what the situation is with mortality. With level expense premium, this means that early premium is insufficient to pay for early expenses, and the excess expenses have to be paid with future premiums, hence the negative reserve. You could also just elaborate on the calculation done in the previous part. The first year expenses are more than the expense loading. So at time 1, the accumulated value of expenses will exceed the value of expense premiums collected. Since the reserve is the accumulated value of expense loading received less value of incurred expenses, it is negative at time 1. For Part D, the full preliminary term method, by definition, has reserve at times, the net premium reserve at time 1 equal to 0. And the renewal net premium under full preliminary term method is the premium calculated as if the policy was basically restarting at time 1. So it is, in this case, for $100,000 benefit, premium paid over 9 years for coverage on 51-year-old over the next 19 years for the same type of policy. So in this case, remaining years, that's 19-year endowment. So it's 100,000 times A51 colon angle 19 divided by little a double dot 51 colon angle 9. And then we note that we can write A51 colon angle 19 as A50 colon angle 20 minus, this is the cost of life insurance in the first year, but all this as written is at age 50, so to actuarially accumulate it to age 51, which is the age at which A51 colon angle 19 is calculated, we divide it by 1E50, which is P50 times V. In this case, V is 1.06 to the negative 1. And the same way, we can view A double dot 51 colon angle 9 as A double dot 50 colon angle 10 minus 1, then actuarially accumulated to age 51. Now, of course, the denominators in the two fractions cancel, and we get what you see here. And all of these quantities we calculated before, or we get them from the table. Q50 is in the table as 0.00592. So we plug in all those values and we do the calculation, and we get approximately 5,404.249218. Therefore, the full preliminary term net premium reserve at time 2 is the FPT net premium reserve at time 1 plus the premium paid then accumulated to the end of the year minus the death benefit paid at the end of the year divided by the probability that we still need the reserve, which is a version of the standard recursive reserve formula. All of the quantities here are known. We plug them in and we get 2V FPT to be 5,119.37053. The FPT net premium reserve at time 19 is calculated just as the present value of future benefit, as there are no future premiums available, so that it's 100,000 times A69 colon angle 1. Now, since this is an endowment, the benefit is paid at the end of the year with certainty, so this is just a present value with the interest rate of 6% of 100,000, which comes out to be about 94,339.62264. The full preliminary term method adjusts net premium reserves to approximate gross premium reserves by implicitly assuming that the first year premium, other than the pure mortality protection for the first year, so the cost of 1 year term life insurance, is spent on acquisition expenses. It basically creates expense allowance from what would normally be level benefit premium or level net premium part that doesn't cover the mortality in the first year. So all of this portion of the premium becomes available for expenses. This reduces the initial strain on surplus from new business, such new business typically requiring substantial acquisition expenses. So paying the agent or paying for advertising and other expenses with cost of issuing a new policy. Please remember this is copyrighted material. The problem itself comes from Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.